The process of condensation polymerization involves a reaction between smaller compounds, called monomers, which bond together and eject a simple molecule, such as water, ammonia, or hydrogen chloride. This reaction continues, producing long-chain compounds known as polymers. An example of a commonly used polymer is nylon. Nylon 6,6 is composed of the two disparate monomers adipic acid and hexamethylene diamine. Adipic acid is a type of carboxylic acid characterized by the carboxyl groups found on both ends of the compound, and hexamethylene diamine is a type of amine, characterized by the amine groups found on both its ends. In the case of producing nylon, the different functional groups belonging to the monomers bond together to produce a small water molecule which exits the compound, leaving the carboxyl and amine groups bound together. This makes the resulting nylon dimer a type of amide, characterized by the newly formed carboxyl amine group. Such is the case with nylon. The bonding of different monomers often results in a polymer chain with alternating components. To illustrate this example further, let's take an analogy. Here is a brick, which will represent one of the monomers involved in a brick-laying polymerization process. The cement on top of the brick will be representative of the functional group belonging to that brick monomer. When a second brick is placed on top, which represents the second monomer in the polymer chain, some of the cement is expelled from the brick stack. This lost cement is representative of the small molecule which leaves the newly formed compound. For a perhaps more empathetic example, take the analogy of people, each person representative of a bonding monomer. Both are carrying a bag each, the bag being representative of the functional group. The two people need to join hands because maybe they're taking part in a ceremony, but in order to join hands they must first put down their bag so that their hand is free. The bags being put down on the floor is representative of the small molecules being ejected from the compound so that the monomers can bond. Then, as the group of people who join hands increases, so does the number of bags being put on the ground. The long chain of people is representative of the long chain polymer. The polycondensation process typically requires the input of heat or applied pressure to allow for bonds in the functional groups to be broken and rearranged. Once the initial step in polycondensation has taken place, larger pieces of the polymer begin to bond together, increasing the length of the chain. The process follows from monomers initially to dimers, to oligomers, to short-chain polymers, and then eventually to long-chain polymers. When condensation polymerization occurs on a large scale, the small molecule byproduct must be continually removed from the reaction vessel to facilitate the formation of the polymer. The polycondensation process involved in making nylon is one of two different types. Esterification is the first, which produces polyesters, and amidation is the second, which produces polyamides, informally known as nylons. Polyesters, such as nylon 6,6, possess high tensile strength, elasticity, moisture absorption, and thermoplastic properties. This makes them useful for everyday applications in clothing and textiles, safety equipment, and outdoor gear.